Good morning, friends. In last lecture, we had seen the analysis of singly reinforced section. In that, we had seen the types of limit state. In that, there are three types of limit state, that is limit state of collapse, limit state of serviceability, and limit state of durability. In that, what is limit state? This limit state is nothing but it is the acceptable limit for the safety and serviceability of the structure before failure occurs. That is very important. This is an ideal method. This limit state method is an ideal method which takes into account the ultimate strength of structure and also the serviceability and durability requirements. That is, in limit state, we are going to know the acceptable limit for what, that is serviceability, durability, and it should fit for all the loads coming on it. Accordingly, there are certain assumptions, and those assumptions were dictated in last lecture. But in limit state of collapse, there are different limit state of collapse. In that, limit state of collapse in flexure or blending, limit state of collapse in shear, limit state of collapse in torsion, limit state of collapse due to axial loading. These are the various consideration in limit state of collapse which we had seen in last lecture. Also, in limit state of serviceability, it consists of cracking, deflection, vibrations, etc. All these we know in last lecture. But now, when we are going to design the problems, in designing problems, we must know which type of section we want to design. That section means that is balanced section or underimposed section or overimposed section. These sections are based on the neutral axis of the beam section. The neutral axis is denoted by XU, and after loading, this neutral axis shifted upwards or downwards. That limit is denoted by XU limiting. Depending on XU and XU limiting, that is actual neutral axis, and after loading the neutral axis, when we are going to compare, then in that, if the section is balanced section when XU is equal to XU limiting, and when XU is less than XU limiting, then that section XU is less than XU limiting, then that section is known as overimposed section. But these sections are not allowed, so you can design such sections as balanced section. And if XU is greater than XU max, then such sections are underimposed section. That is, we must calculate these values of XU and XU limiting for getting the moment of resistance in a beam section. So we will start with the analysis problem. That is, first one is analysis problem. In that, in such type of problems, first given data is FCK, that is concrete grade is given, Fy that is steel grade is given. These steel grade are Fe 250, Fe 415, Fe 500, FCK M15, M20, M25, M30, and AST. AST is the area of steel. And we have to find the ultimate moment, that is Mu, and allowable load on given span. Suppose there is a simply supported beam, it carries a UDL or it carries a point load. What amount of load carried by that beam we have to calculate, and also we have to calculate the ultimate moment of resistance. For that, the following steps are adopted. In that, first step is to calculate XU max. That is, XU max, it depends on the percentage of steel, and it is given in last lecture. See here, these are the values for XU max. For Fe250, XU max is 0.53D. For Fe415, XU max is 0.48D. For Fe500, XU max is 0.46D. These are the XU max or XU limiting. You can denote it as XU max or limiting value or XU limiting. You can write down anything, no problem. Then here is the first problem of analysis type. In that, you have given FCK, Fy, width or depth. This is analysis problem. In that, you have given FCK, Fy and AST. Then we have to calculate XU max accordingly, that type of steel grade. Then second one, you have to calculate XU. This XU, how this formula comes, last lecture we have derived this one. That is XU is equal to 0.87 FYST upon 0.36 FCK B into D. Then compare XU and XU max, or XU and XU limiting. If XU is less than XU max, section is under reinforced section. If XU is equal to XU max, section is balanced section. In above cases, consider XU for calculation. If XU is greater than XU max, section is overimposed section. Hence, consider XU max for calculation. These overimposed sections are not allowed in limit state method. So when XU is greater than XU max, when there is a overimposed section, you have to consider it as a balanced section, and you have to calculate the moment of resistance. Then calculate maximum stress in steel Fy by the equation Mu is equal to 0.87 FYST into bracket D minus 0.42 XU. Then obtain MD or Mu in term of working load, that is design load, and span L, equation it with equate with Mu to get unknown load and hence working load. Then next, problem 1, depending on first type. Find moment of resistance of a RCC beam 230 mm wide and 550 mm deep, effective, that is effective depth is given, reinforced with 4 22 mm diameter bars on tension side. Use M15 concrete and MS reinforcement. MS means mild steel reinforcement, that is Fe250 steel grade. Then we will start with this problem, analysis problem. Then type 2, these are the again analysis type of problem. Here you have given FCK, B, D, Fy, and you have to find Mu and AST for balance section. And for that, steps are as below. Calculate XU max, find Mu limiting, from Mu limiting is Cu into Z. These formulas are given already. Find AST. See here, in first type, you have to calculate XU and XU max. But in type 2 problem, you have to only calculate XU max. You have to directly calculate XU max, because in such type of problems, you have given width, depth, then you have to calculate directly XU max. So this XU max can be calculated by the steel grade, that is Fe250, Fe415, Fe500. For that, different XU max values are given. You have to put those values and calculate directly XU max and then find mu limiting from equating mu limiting to CU into Z. And lastly, you have to calculate AST maximum. This is type 2 problem. Then next type of problem is type 3, that is design type problem. In that, you have to design a section, and that section you have to design for a balanced section, because balanced sections are most economical section. So you have to design the section for balanced section. In that, you have given FCK, that is concrete grade, FY, that is steel grade, width or B by D ratio, and mu limiting. These values are mu are given. To find B, D, AST for balanced section, for that steps are: first step, calculate design parameters. Those design parameters are mu limiting or FCK, FY, all these design parameters you have to calculate. Then calculate factored moment as MD is equal to, or mu is equal to, factor of partial factor safety into M. M is the moment acting on the beam. Equating this mu limiting to MD, this mu limiting is calculated again from steel grade, that is for Fe250, that mu limiting value is 0.149 FCK BD square. For Fe415, mu limiting is 0.138 FCK BD square. For Fe500, the mu limiting value is 0.133 FCK BD square. So equating mu limiting to MD, that we have calculated here. Then calculate D. Then calculate AST by using this formula and assume appropriate cover and determine practical overall depth of the beam section. So depending on this, we'll start a first problem on first type. That is, we have to find the moment of resistance of a RCC beam 230 mm wide and 550 mm deep, effective, reinforced with 422 mm diameter bars on tension side. Use M15 concrete and MS reinforcement, that is Fe 250 steel grade. So the given data is B is equal to 230 mm, D 550 mm. Here this D is small d, by printing mistake it is taken as capital D. Actually this is small d, that is Fe2 depth, that is 550 mm. AST, you have to calculate the AST, that 4 bars are given of 22 mm diameters. So 4 into pi by 4 into d square, that is 1520.5 mm square. M15, that is FCK 50 Newton per mm square. Mild steel reinforcement is given, that is Fe Fy 250 Newton per mm square is given. Then you have to calculate, in that first step is to calculate XU max. So for Fe250, here steel grade is given Fe250, therefore XU max or XU limiting value is 0.53 D. So calculate XU max 0.53 D, that is 0.531 into D 550, that is XU max of 292.05 mm. So XU is equal to 0.87 FYAST, 0.36 FCKB. That is, you have to calculate first XU max, then you have to calculate XU, and this XU is 266.27 and XU max value or XU limiting value is 292. That is, XU is less than XU limiting or XU max. So the section is underimposed section. It is no problem. When the section is underimposed section, you have to equate mu is equal to Tu into Z. When section is overimposed section, you have to equate here Cu into Z. So remember, when the beam is underimposed section, you have to equate mu Tu into Z, and when the beam is overimposed section, you have to equate here Cu into Z. Cu is the compression, ultimate compression, and Tu is the ultimate tension. This ultimate tension is given by 0.87 Fy AST. So put Tu 0.87 Fy AST, Z is the lever arm and is given by D minus 0.42 XU. So mu is equal to 144.85 kilonewton meter. Okay, thank you. We'll start next problem next lecture.